Welcome back to YMT112 Algorithm and Programming 2. We are still discussing questions of Chapter 15, Recursion. We have already covered first and second question, and I said I would say about this problem something at the end of the video. I forgot. Now I will say it now. So what we did in the previous video about calculating the multiplication of integers by recursively summing up a number of times these values. Either you go 4 times for 5 or 5 times for 4, it's up to you. But what if these numbers were not integers? How can you solve it? Try to do it on your own. It has a simple idea you need to address. You can do it recursively or iteratively even if you are just summing up. But how can you do it if it is not integer? Think about it. If you get any problem, just get back to me. Now let's move to the third question. Repeat the same concept of question 2 to produce the power of a number x to n. So x to power n in this case can be produced also by a recursive or iterative process by not summing up, by multiplying. So if we are going to raise x to power n, that means we multiply x by itself n times. So let's do it recursively. I have already created a file here, so that a class, so that we save some time for this video. Now, for simplicity, I'll just pass to the function, or to the method here in this case. I'll pass to it directly from the main program, or from the main method, 2 values. So I have to create a main method first. Okay, and what I'm going to do, so we have to create a recursive method. So in order for me to do that, I need to define this method. So I will call it, I need to display directly. So in that case, I'll do like this. Okay, let me display. So I'm going to display what? Let's use 2 to power 4, or 2 to 4, 2 to 4, okay, equals, and in this case, I'm just calling the method that I will customize. I'll call it recursive power, and I'll pass these two to the base and 4 the power. All right, now I'm done with the main. I need to customize my recursive method. For this recursive method, we are creating a static method. It belongs to the class here, static, not void, it's integer. Because also we are speaking about integers here. If you want also to address other than integer, that means floating point, think about it. It's a bit similar to the way you can multiply other than integer recursively or iteratively, okay? And here I type the name of the method, recursive pow, and then I pass the arguments. Sorry, I receive the arguments here. I don't pass them. I have to assign them to 2 variables, to these 2 parameters. We can call them m and n again. Okay. So what are we going to do? We need to have the base if n is greater than 0. Okay. Now, if it is 0, what happens? If it is 0, then you return 1. The value is 1. Here, if 2 is raised to power 0 to 0, that means the output or the outcome is 1. If negative, we are not addressing it. You can think about it, because I'm not speaking, it's that's division. It should be greater than 0, okay? Or at most, or at least, sorry, not most, at least it should be 0. If negative, instead of multiplying, you need to divide, right? Okay. So in that case, I'll return something. Here in this case, I'll return a recursive process of multiplication. So I'm going to return the multiplication of m okay? By recursive, I call my method multiplication, pow. Call the method itself. And then I pass what? M is not changeable. Keep it the way it is. And N has to change. So as I said earlier, either you pass the pre-incremented N or you pass N minus 1 each time. Okay. Now, I need to terminate, I'm sorry. Okay, I need to terminate here. If it is not greater than 0, if it is 0, then you return 1. Okay, and that's it for this recursive method. It's not really difficult. Let me just run. That's exactly it. And you can customize it the way you like. It's not difficult. Now take it as a task also. What you need to do, you need to calculate the recursive power of negatives. That means 2 to the power minus 4, or 2 to minus 4 in that case. So instead of multiplying here, you need to divide you divide by a certain ratio. It's not dividing m by m by m. You need to figure out the ratio that you need to divide. Okay, think about it, and you need to do it on your own. Okay, this is the end of this question. I have another question, which is a task you should do. We actually solved a very similar question to it last chapter. It was the last question, I guess, about the circles, that concentric circles. And now what I created is these concentric, if we can call it, I'm not sure if this statement is precise, but they have the same center. Like not exactly circles, but they have the same center. I think we can call them concentric in this case. And what you need to do, you need to have a recursive process to create 5 of these, and each time the one inside, like the outer one, is double this one. That means this one is half of this, and the next one is half of this one, which is quarter of the outer, and so on. So you should do it. If you think or wonder from where I should start, what should be my reference, you can use this reference, 50 and 50, this left topmost corner. So it would be 50 and 50. Then customize. How about the length and height? Okay, you may think about 200. It's like a square. Okay, so 200 and 200, and then create this output or outcome by a recursive process, not iterative process. Okay, that's it. Actually, this is a very short chapter. There are other examples you may come across, but the idea is very similar. I guess you have already checked or seen the factorial by recursive process, also like some series or special series that we have, like Fibonacci, for example. These have been already covered in your theoretical part, or in the theoretical part of the chapter. And that's it for this chapter. Until our next chapter, have a good time. Goodbye.